Before the video starts, I want to let you know that I'm looking for a talented video editor to join the channel. So, if you're a video editor and you're interested in this opportunity, all you need to do is click the link in the description of this video and fill out the questionnaire. Now let's get to the video. Certain characteristics make even a single fighter jet in a country or territory cause significant discomfort, and it can even trigger a possible conflict between these two nations. This situation becomes even more tense and potentially dangerous when so-called fifth-generation fighter jets are involved, a term many of us have heard, but we have no idea what it actually means. In fact, this is a classification of jet fighters that includes the main technologies developed during the first part of the 21st century, that is, from the 2000s onward. Fifth-generation fighter jet characteristics aren't universally agreed upon, and not all jets in this category have them. However, they usually include stealth capability, low probability of intercept radar, agile airframes with supercruise capability, advanced avionics, and highly integrated computer systems capable of interacting with other elements within the battle space. For situational awareness, these are the most intimidating and advanced fighter jets in operation in the world today. And in addition to that, they come equipped with something called Supermaneuverability. Watch this maneuver that will be performed by this Russian fighter jet, Sukhoi Su-35, during an air show. Maybe you've already seen this same maneuver in a Top Gun movie during the dogfight scene. But maybe what you didn't know is that this was actually a real demonstration maneuver of this fighter jet's supermaneuverability. The name of this maneuver is the Pugachev's Cobra, and only a few fighter jets in the world are capable of performing it correctly and safely. Supermaneuverability is a combat aircraft's ability to perform tactical maneuvers impossible with only aerodynamic techniques, especially at high angles of attack and in low-speed situations. Such maneuvers can involve controlled lateral sliding or high angles of attack. Beyond the maximum lift limit, these maneuvers are not possible for conventional aircraft without the risk of stall, loss of lift, or other aerodynamic failures. An aircraft is supermaneuverable when it is able to exceed the design limits of pure aerodynamic maneuverability, performing maneuvers far beyond its design limits, but in a safe way and without losing control. When this point is reached, it becomes supermaneuvered. Supermaneuverability is important in three critical situations in close air combat, known as dogfight, where the ability to maneuver quickly to gain an advantageous position over the enemy can be decisive. In evasive maneuvers, where the ability to perform extreme evasive maneuvers can be essential to avoid, and most importantly, dodge guided missiles. And in capability demonstration, where supermaneuverability is used in military exercises and air shows, demonstrating the aircraft's maneuvering and control capabilities. The tail slide maneuver is an aerobatic maneuver that starts from level flight. Next, the aircraft enters a straight vertical climb at high power. Since fighter jets have a high thrust-to-weight ratio, they can maintain this condition with the nose pointing straight up, completely stalled. The pilot keeps the aircraft in exactly the same position for as long as possible, until the speed reaches zero and the aircraft completely loses thrust. And it starts to fall straight down, with the tail pointing toward the ground. That's where the name tail slide comes from. After a brief drop, the nose drops abruptly and the aircraft enters a dive, and shortly after, it recovers to level flight. The tail slide maneuver will temporarily reverse the airflow over many surfaces of the aircraft, generating abnormal forces compared to forward flight. The control surface linkages must be able to handle these forces without damage. Not all airplanes capable of performing aerobatics are also capable of performing the tail slide maneuver, especially because it is best performed when the aircraft has vectored thrust engines. The flat spin maneuver, or flat spiral, is highly dangerous, even for fifth-generation supermaneuverable fighter jets. unlike a spin, or a regular spin, where the nose of the plane points downward while the aircraft spins around its own axis. A flat spin occurs when the aircraft remains almost level with the horizon, but falls spinning around its vertical axis, with the nose always pointing forward, as if it were stable. The danger lies in the fact that the aircraft has zero or almost zero forward speed. This causes very little or almost no air to flow over the wings and control surfaces, using almost completely, making it extremely difficult to recover from this uncontrolled spin. This is usually not an intentional move in a fighter jet dogfight, as it's dangerous and generally unwanted. The Vulture Bell Maneuver, or Vulture Bell Maneuver, is an impressive maneuver performed by highly maneuverable fighter jets, in which the aircraft leaves level flight and begins a rapid vertical climb, immediately followed by an abrupt drop to one of the sides, thus performing a 360-degree turn and immediately returning to level and stabilized flight. Incredibly, the maneuver was performed accidentally for the first time in 1988 by the Soviet test pilot Anatoly Vulture at the Paris Air Show aboard his MiG-29. The maneuver is known for being extremely challenging, both for the pilot and for the aircraft. This maneuver demonstrates supermaneuverability and can only be flawlessly performed by supermaneuverable aircraft. The maneuver can indeed be used effectively to evade older and less agile and capable missiles, since modern ones are extremely and highly maneuverable. It can also be used in dogfights to abruptly change position, moving from the vulnerable front position to the advantageous rear position. The Herbis maneuver, also known as the J-turn, is an aerial combat maneuver that uses post-stall technology such as thrust vectoring and advanced flight controls to achieve high angles of attack. The Herbis maneuver allows an aircraft to quickly reverse direction using a combination of high angle of attack and rolling. The maneuver begins with the aircraft entering a very sharp, tight turn. Next, the pilot uses thrust vectoring and flight controls to increase the aircraft's angle of attack to a very high level. This allows the fighter jet to almost stop in midair for a brief moment. Then it turns sharply, almost 180 degrees, changing direction almost instantly and resuming flight. The maneuver was performed for the first time in April 1993 by an X-31 during aerobatic displays. The Pugachev's Cobra maneuver, also known as the Cobra maneuver or dynamic deceleration, is a dramatic and demanding maneuver. In this maneuver, an aircraft flying at a considerable subsonic speed abruptly raises its nose, momentarily to a vertical position and slightly beyond, causing an extremely high angle of attack and momentarily stalling the aircraft, acting as a full-body air brake, and then quickly returning to the normal flight position. If performed correctly, the aircraft will not effectively change altitude nor roll to either side. It seems simple, but the maneuver requires precise pitch control, stability, proper engine power adjustment, and high pilot skill. Being the key factor, the entry speed into the maneuver. If it is low, the aircraft may be unable to complete the maneuver or return to level flight. If it is too high, in supersonic flight, the aircraft can create high G-forces that may cause pilot unconsciousness or severe fuselage damage. The maneuver briefly disrupts laminar airflow over the wings, preventing the aircraft from climbing. The Cobra maneuver exemplifies supermaneuverability, particularly as a post-stall maneuver. It can be used in real dogfight scenarios to gain an advantageous position over the enemy fighter extremely quickly and precisely. The Air Beast maneuver and the Cobra are often performed by 4.5 and 5th generation fighter jets using thrust vectoring. These include the Sukhoi Su-35, the Sukhoi Su-57, the F-22 Raptor, the F-35 Lightning, among others. The maneuver is named after the Soviet pilot Viktor Pugachev, who was the first to bring it to the public's attention. The Kulbit, or Frolov's chakra, is an aerial maneuver created by Russian pilots. It consists of the aircraft performing a very tight circle or loop, often about the size of the aircraft itself. It is an example of a post-stall maneuver, a type of supermaneuverability like most post-stall aerobatics. It demonstrates control of the aircraft beyond normal flight conditions where control is usually possible. Aerodynamic flow can be controlled only by elevators and stabilizers. The name Kulbit means somersault in Russian, while Frolov's chakra refers to the Russian test pilot Yevgeny Frolov, who was the first pilot to perform this maneuver. Chakra means millstone. The first fighter jets to demonstrate supermaneuverability appeared in the 1980s, mainly with the development of thrust vectoring technologies. That's when the engines move along with the movement of the flight control surfaces, like the rudders and ailerons that make the fighter jet turn. Also because of advanced flight controls. These aircraft were mostly of Russian origin, such as the Sukhoi Su-27 and Mikoyan MiG-29. Later they were followed by the American Michael Donnell Douglas FM-15 Active and Rockwell Messerschmitt Bokov Blohm X-31. Supermaneuverability was initially researched in 1975 at the Langley Research Center in the United States, which resulted in the development of the McDonnell Douglas F-15, Short Takeoff and Landing Maneuver Technology Demonstrator, with the acronym standing for Short Takeoff and Landing Maneuver Technology Demonstrator. This aircraft was basically a modified F-15 Eagle. Traditional aircraft maneuverability is achieved by altering the airflow over the aircraft's control surfaces. These include the ailerons, elevators, flaps, air brakes if the aircraft has them, and the rudder. Some of these control surfaces can be combined, such as the rudder vaders found in the V-tail configuration of some aircraft. But the basic properties are not affected when a control surface is moved to present an angle to the airflow passing over it. This changes the airflow around the surface, altering its pressure distribution, and thus applying a pitching, rolling, or yawing moment to the aircraft. This is the basic principle that explains aircraft maneuverability. The speed at which an aircraft is capable of its maximum aerodynamic maneuverability is known as corner eye speed or corner speed at any higher speed. Control surfaces stop at maximum deflection because of structural stress or airflow-induced instability. Turbulent air over the control surface at any lower speeds causes the deflection of air over the control surfaces to be considerably less, and consequently, the force generated to maneuver the aircraft is reduced, and so the aircraft will not turn at its maximum rate. If the phenomenon occurs under the wings, they won't generate enough lift and the aircraft will stall. However, when an aircraft is or becomes supermaneuverable, it is able to remain maneuverable even when it exceeds the design limits of purely aerodynamic maneuverability. That is, even when the airflow passing over the control surfaces, as well as the wings, is far beyond the maximum limits established for the aircraft's design. Or in other words, even when the corner airspeed is exceeded, either above or below, completely disabling the aircraft's conventional maneuvering mechanisms. From then on, the aircraft relies heavily on vectored engine thrust. In other words, to sum up, supermaneuverability is the ability of an aircraft to remain perfectly maneuverable even when the airflow over the wings and control surfaces is severely disrupted or non-existent, whereas a regular aircraft, under these conditions, would simply fall out of the sky. A supermaneuverable aircraft can be partially or fully controllable.